So, the last theorem for today, which is theorem 4, states that the opposite angles of a cyclic quadrilateral are what? Supplementary. When they say quadrilateral, quadrilateral is a four-sided shape. You can have a kite, a rectangle, a square, and the likes. So quadrilateral is a what? Four-sided shape. This cyclic is actually explaining that we have the vertices of this quadrilateral embedded or encompassed in the what? Circle. So this is what makes it a circle. So a cyclic quadrilateral is a quadrilateral in a what? In a circle. And when they say an angle is supplementary, angles are supplementary, mathematically, supplementary angles are angles that add up to what? To make 180 degrees. Now, the theorem now says that the opposite angles of a cyclic quadrilateral are supplementary. Opposite angles in the sense that angles facing each other. The opposite angles, they add up to give us 180 degrees. So if you should add these two, you must have 180 degrees. The same thing here. If you should add these two, you must have what? 180 degrees. Opposite angles of a cyclic quadrilateral are what? Supplementary. They add up to what? 180. Here we go. I have questions here for your consumption. Now the first question here. You have to find A and B. Now if you have to find A, it is very simple. I told us that what? Opposite angle. The theorem states opposite angle of cyclic quadrilateral are what? Are supplementary. That is, they add up to make what? 180 degrees. So you tell them that to obtain this A, which is EBC or CBE. EBC, when you add EBC to this one, that is, when you add EBC, EBC represents A. So you add EBC to this one here, because they are opposite to each other, to EDC. You add EBC to EDC, and the EDC is actually what? 80 degrees. So they add up to give you what? 180 degrees. Why? You tell them that opposite angles of what? Of cyclic quadrilateral. Opposite angles of what? Cyclic quadrilateral. So they add up to what? 180 degrees. So you have your answers what? 180. Do this one. That is what? Collect like terms. So you have what? A to be equals to what? 100 degrees. I hope you grab that. Now, for us to find the B, I told us that opposite angle, the term state opposite angle B adds its opposite angle to be what? 110. So you add the two, they must make up what? 180 degrees. So you tell them DEB, which is what? The 110. When you add DEB to what? DCB or BCD, you must have what? 180. And why must you have 180? Tell them opposite angles of what? Of cyclic quadrilateral are what? Supplementary. They are what? Supplementary. So you have BCD, which is the A. BCD is our B. B equals what? 180 degrees. Now at this point in time, what? Collect like terms. Then you finalize. So you have this to be what? 7 degrees. So that's that on the first question. Now let's proceed to the second question we have here. Now you have been asked to find what? Find X, Y, W, and what? And Z. Now, stemming from the principle I stated earlier that opposite angles of a cyclic quadrilateral are supplementary. Now look at this. This 126 will have its opposite angle as what? As Y. Look at the cyclic quadrilateral. It's within, forget this one outside. Now they call it cyclic quadrilateral. It must be is a quadrilateral within a what? A circle. Now can you see this? So forget this Z shape outside. So you have this. So this one is what? is opposite to what? They are what? Opposite to each other. So I can easily get y. So you tell them when you add y and 126, you must have what? 180 degree. You have to state the same reason that opposite angles of what? Of a cyclic quadrilateral. Of a cyclic quadrilateral. So you continue. That is our what? Supplementary. So you collect like terms at this point in time. You have 180 degree minus what? 126. And that will give us what? You have 4 here, you have 54. Now, having gotten y, you can easily get z. Now let me bring the shape out for you. Look at the angle connecting y and z. So you have y, you have been asked to find z. This is what? Angle meeting at a point. No, this is angle on the what? Straight line. Angle on the what? Straight line. You should remember this, that you have been taught. Angle on the straight line adds up to what? 180 also. And you have the y to be what? 54. So you tell them, when you add y and z, you must have what? 180 degree. Y, angle on the what? On a straight line. So you have y to be 54 degree plus your z equals to what? 180 degree. Then you what? Collect like terms. So you have z to be what? 180 degree minus what? 54 degree. And that will give us what? We have 6 here. We have 1, 2, 6. That's that on that. Now, for you to get, so we have gotten y and z. So we have y to be what? 54. So my y is what? 54. I have y to be what? 54 degree. Now, since you've gotten y, I can easily get x. You know why? If you remember the theorem 1 that says, at this y here, this y that I've gotten, if I should locate the point, this is a circumference. And this point here, x, that I want to get now, the x that I'm trying to obtain now, at this point here, I have x to be the what? Center. So remember your theorem 1 that states, angle at the center is twice whatever you have at the what? Circumference. So to get x now, you tell them x is 2 times whatever you have here. So what do you have here? So x is 2 times y. Why is x 2 times y? Tell them angle at the center, to obtain angle at the center equals to what? 2 times angle at the what? At the circumference. So now you have y as what? 1, 2, 6. So y, we have y as what? No, we have our y to be 54, sorry. We have y to be 54 degree. So that means 108 degree. 108 what? Degree. That is that and that. So if I have y, I have x to be 108 degree. If I have x, I can easily get w. I've solved something related to that earlier. So now, if I want to get what? My w, I'll bring it like this. That if I have to get w, let me bring out diagram so you get it better. I have x here, and I have w here. So now, this actually forms a circle too. You can see this. So remember your what? Angle meeting at a point. So you tell them, when you add x and w, you must have what? You must have 360 degree. The reason behind that is what? Angle at a what? At a point. So angle meeting at a point. So, and your x is what? 108. So you tell them 108 plus w equals to what? 360 degree. Angle meeting at a point. So you collect like terms. So you have w equals 360 degree minus 108. So at this point in time, I have what? I have 2 here, I have 5, I have 2. I have 2, 5, 2 as my what? Answer. I hope you get that. That is that and that. Now I move straight to question C. Now permit me to rub this off. Now, you have been asked to calculate the angle of what? Of x. Now, theorem 4, I want to apply theorem 4 on this. I told us that angles of a cyclic quadrilateral, opposite angles of a cyclic quadrilateral are what? Are supplementary. But here we have not a cyclic quadrilateral. this isn't a cyclic quadrilateral. Do you know why? I told you that a cyclic quadrilateral has its vertices touching what? Touching the circle. Are you getting it? It must touch the circle. The vertices are what? Has the vertices touching the what? Circle. Now look at it. We have 1 here, 1, 2, 3. The last one is not what? Touching. The fourth one here is not touching the circumference. So what you can actually do is to extend this. Using, you extend this. Are you getting it? You break the lines in order to tell the examiner that this isn't part of your question. I actually did that on my own. So you will extend this to formulate the word cyclic quadrilateral. So at this point in time, I now have a word, a cyclic quadrilateral. So if I add x here, are you getting it? At this point, I have a cyclic quadrilateral. So from here now, since you have this, you can actually obtain the value here. And once you add this, you can compare with this, saying what? They are opposite angles. Then you get your answer. Now, how can you get this? It is very simple. If you remember, this is our word, center. And we have this to be our word, circumference. So apply the theorem. The theorem says, angle at the center, for you to obtain the angle at the center, it is twice, are you getting it? 2 times whatever you have at the word, circumference. But here, you've been given an angle at the circumference. All you just have to do is to reverse the theorem by saying angle. You just tell them that if you are to get, let me label this. I have PQR. Let me just label this X. Let me label this X. So you tell them to get PSR, to obtain PSR. To obtain PSR, you tell them it is equal to what? Half of POR. Half of this POR. Why? You tell them angle at the circumference is half angle at the center. So now if you have to get that, you have half of what is POR? 114 degree. You have to divide 2 in 11, 5, remainder 1, 2 in 14, 7. So I have what? 57 degree as my word, PSR. But don't forget, the question asks you to find what? X. And let's concern with this. So now, since I have this place to be 57 degree, it is opposite to X. Now you remember your theorem 4 that states that what? Opposite angles of cyclic quadrilateral are what? Supplementary. So you tell the examiner that when you add these two, it must be equals to what? 180 degree. Now let's see. You tell them PSR, you tell them PQR. When you add PQR, the PQR is X. To your PSR, you must have 180 degree. Why? Opposite angles of what? Of a cyclic quadrilateral. Of a cyclic quadrilateral, they are what? Supplementary. So you have your PSR to be what? 57 degree. Equals what? 180. And at this point, you collect like terms. X equals 180 degree minus 57 degree. Then I have what? I have 3 here. I have 2 here. I have 1 here. So that is what? 1, 2, 3 degree. And that is that. Please, I need to say that I've extended this. You have to inform the examiner that you actually did this. So you tell them, extend POR to what? To get your what? X. So you tell them, extend POR to what? To have your what? To X. Are you getting it? You have to extend this POR to have your what? To have your PSR. So that is what we actually did. And that is that on theorem 4. So thank you.